Hello everyone. Today our topic is probability. We are going to solve a few examples about the topic. We will distinguish theoretical and experimental probability and we will participate in a game show together. Let's start with remembering how to find probability. Probability of an event is number of ways the event could happen divided by total number of possible outcomes. And here you see impossible and certain events. For example, seeing a dragon in real life is impossible, so its probability is equal to 0. On the other hand, if I say the sun will rise tomorrow, it becomes a certain event, so its probability is equal to 1. What about equally likely events? If I toss a coin, I will get either head or tail. So its probability is a half, as you see here. When I roll a die, I can get 1, 2, 3, 4, 5 or 6. So having 6 is 1/6 probability. Likewise, picking card from this deck of cards is, yes, 1/4 because I have 4 cards here. And as you see, these two events are called as unlikely events because they are less than half. Let's change the color. Good football team winning a match or a train arriving on time are examples of likely events because they are greater than the half, but they are not certain as well. Okay, let's continue. Here I have a question for you. You will roll 2 dice, and if you choose the option A, you will receive $5 if you get a double. And if you choose option B, you will receive $5 if you get any 2 even numbers. So, I want you to go to Padlet and write which option you choose with your explanations. I give you 2 minutes for this, and we will discuss after the 2 minutes. See you. Okay, let's discuss the question together. Here you see a table for all the possibilities of rolling 2 dice, and in the upper part their sum is written. So let's find option A, which is getting doubles. If I want to get doubles, I should have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So how many chances do I have? Yes, 6 out of 36 because here as you see I have 36 options if I roll 2 dice, and if I simplify this I will reach 1/6. Okay, what is the probability of option B? Which means getting any events. And here you see all the events, and also you notice that I have 2, 4 and also 4, 2. So how many chances do I have for this option B? Yes, I have 9, and again out of 36. If I simplify this, I will reach 1/4. So which option, A or B, makes sense? Which option should I choose to gain money? Yes, I should choose option B. Why? Because 1/4 is greater than 1/6. Yes, we should prefer option B to gain more money. Let's continue with the other example. In a box of 20 marbles, there are 2 blue, 4 green, 6 red, and 8 orange marbles. Find the probabilities of picking all the colors respectively. So this time I am giving you 1 minute to solve it, and then we will solve this together. Please note in your notebooks the question and your solution. See you in a minute. Okay, let's start with blue marbles. So I have 2 blue marbles, and out of what? 20 marbles. So the probability of picking the blue ones are 2 divided by 20, and it is equal to 10%. What about green ones? I have 4 greens. Yes, and I am writing this in this way, and I am simplifying, and I will reach 20%. What about red ones? 6 out of 20. I will simplify this again, and I will reach 3 out of 10, and which is equal to 30%. And finally, the orange ones. It is 8 out of 20, which is equal to 40%. Yes, we find all the probabilities. Good job. But if we do the same operation over again, will we reach the same results? Or if we do this 100 times, 1000 times, the probability of picking the blue marble will be 10% again? What do you think? Okay, to understand the question better and visualize it, let's go to CODAP. CODAP is an online tool for displaying and analyzing the data, and it allows us making graphs to visualize it. It is so useful for probability. And here you see our sampler, respectively our sample question, and there will be a graph after we realize our experiment. Okay, so I want to pick one item out of these 20 samples. Here is also a spinner option, and you can see that since we have more orange marbles than the other two, its proportion is greater than others. And at the same time, since we have less blue marbles than others, its proportion is less as well. Let's go back to mixer position, and now I am starting our experiment. I can fast a little bit, and here you see our number of colors. Here you see the numbers. Yes, 19 and 20. Yes, our experiment 1 is done. So let's look, and we can choose the percent option to see related percentages. But these data, actually our results, are different than what we found, right? For example, we said that the blue marbles will be 10%, but it is 20 here. And green marbles, we said 20, but here it's 10%. Is it wrong? Or what is the issue here? Okay, let's try one more and do our experiment 2, and then look the results again. Here it is happening now. You see the numbers and related percentages. Yes. It is again different than the first one this time. Blue marbles is 15%, and the orange ones are 45%, but we found orange marbles should be 40%. Okay, now I am going to do our experiment for the one last time, and then we will analyze our data together. It's red, orange, orange again, orange, green, and this time no blue. Is it possible to have no blue? Oh, yes, it is possible according to this animation. And it is 0%. Oh, interesting. But we found 10% and it says 0%. Okay, it is not wrong. There is nothing false here. I will explain all this time. So, I am taking sample size, and you see that actually we have all actually we have almost the same results as we did in PowerPoint slide when we look the total results. But when we examine experiments one by one, there are diverse results like 0% for blue marbles. So, what can we conclude? But before the conclusion, let's do the experiment again and examine this graph this time. Rather than experiment 1, experiment 2. We will look all the results together. If orange comes, the orange numbers are increasing, and here you can follow the percentages and the numbers coming from this box. I am doing again with the fastest mode to see the results easier and faster way. I am doing, and I am increasing the number of experiments actually. What do you notice when I increase the number of experiments? Please pay attention to the percentages and remember what we found before in PowerPoint slides. And I am doing the final ones and I stop here. We did 500 cases and 25 experiments, which means we pick marbles from the box 25 times. And now, think about our graph a little bit and tell me what you see. For example, we found respectively 10, 20, 30 and 40 percentages for blue, green, red and orange marbles. And when I increase the number of experiments, I almost reach the same results. And here in orange, it is 40%, right? What about the other ones? This is 32, 18, 9.6%. Why do we have any difference? What we did before is wrong? It is not wrong, of course. Let's go back to our PowerPoint presentation and look why. This is what we found before, and we did CODAP. And probability gives us numerical results of likelihood of an event, and it is divided into two as theoretical probability and experimental probability. In theoretical probability is what we expect to happen, and it is certain, as we did while we are solving the marble example in the PowerPoint slide. On the other hand, experimental probability is what actually happens when we try it out. as we did on CODAP. We reached the experimental probability there. And experimental probability is frequently used in research and experiments of social sciences, economics, and medicine. For example, which party will be selected in the next elections? Is this medicine curable for all people? Since we cannot apply our studies and research or surveys to all of the people in the world or in the country, we select a few of them and apply our research, and we generalize our results. So, it is experimental probability. You can think we are generalizing our results in experimental probability. So, what is the relationship between theoretical and experimental probability? Think about it a little bit. And yes, if we increase the number of the experiments, experimental probability gets closer to the theoretical probability, as we see in CODAP. So we can say that these ones that we calculate are theoretical probability. And these ones, here you see the percentages, are, yes, these ones are experimental probability. Okay, this is time for your homework. Follow the same steps we did in CODAP, but this time I want you to examine the probability of rolling 2 on a dice. You will select sampler in plugins to create your sample, and your sampler should look like this. Okay, you will select one item out of 6 samples. And please answer these questions. What do you expect about the probability of rolling 2 on a dice? What happened when you actually try to roll the dice on CODAP after 25 times and 50 times? If we roll the dice 50 times and find that there is a huge gap between the probabilities of getting 2 and 6, how can you interpret this result? Okay, this is end of the lesson. Please, if you have questions, don't hesitate to email me. See you later.